c square 1 plus uxd ux dash v upon c square. And this value ux dash is equal to c sine theta naught root under 1 minus v square upon c square 1 plus, and what is your ux dash? That value is equal to c cos theta naught v upon c square. And now, if you are going to check what is your ux square plus ui square, ये क्या होगा? Can anybody tell me?
C square.
What is your ux square and ui square? Root under
C.
c. So that value is c. So why we are using this ux is nothing but c cos theta, and we can use this ui is nothing but what? C sin theta. Isn't it? We can easily use this thing because the speed of the light is not going to change. But when we are talking about its component, suppose this component have magnitude c cos theta naught from s dash frame, then this x component will not remain c cos theta naught. It is just going to change because c cos theta naught has some different number which is less than c, and once it is less than c, it has to change. Isn't it? So, but if I am talking about magnitude, and what is meaning of magnitude? This is your ux, this is your uy, this value, the magnitude, you can usually use this Pythagoras law, and ux square plus ui square. So this value is not going to change. You can change this value, you can change this value, but this value, and you will change this and this such that this value will not going to change. So everyone is comfortable? Yes? Okay, good. So let's go for one more question and then we will switch to the next topic. Now, in general, you will see most of the questions, the examiner will give you whether one frame will move in X direction, another frame will move in Y direction or something like this. But sometime they will give you this sort of problem also. And this is also in your tutorial. So I think you have to solve your tutorial. है ना, आपको अपने tutorial solve करने चाहिए. Suppose this is my sigma. And we have two particles. One particle is moving with velocity u, and let's say this particle is A, and another particle is moving with velocity v, and the angle between these two is theta. And velocity of A with respect to sigma, and this is your B particle. So this is your B, this is your A. What we have to do, we have to calculate velocity of B with respect to, or velocity of A with respect to B. Let's say we have to calculate velocity of A with respect to B. And it is given the relative angle between these two particles is always maintaining angle theta. Yes, its velocity is v and its velocity is u with respect to sigma. So how you can approach this sort of problem? कैसे इस तरह के प्रॉब्लम को अप्रोच करोगे? How you will approach this sort of problem? Just tell me. Anyone?
सर साइन और कॉस कंपोनेंट लेके कर सकते हैं?
कंपोनेंट लेंगे,
Can
बट
you
नाउ
take component
you have
of
to
any?
make trick. You have to make trick. अब देखो यहाँ पर x axis, y axis तो कुछ दिया हुआ नहीं है. Are you getting my point? So who can? So at this point of time, you can decide your x axis. So it is very intelligent thing that you have to decide your x axis is something like this. Why? Because you have to calculate the velocity of A with respect to B. So you have to sit on B and you have to calculate velocity of A. Then you can decide it is your x-axis, and then you can take the component of u along vertical and horizontal direction. Everyone is comfortable right now? So, and again we are also saying that this will be my S and this is my particle. So what is my S dash frame? What is my S dash frame?
Sigma.
Sigma. So sigma is my S dash frame. And once you are assuming that this is your x-axis, and if you are sitting on B, then sigma is appear to move into which direction? This in this direction with respect to B? Yes? Are you getting my point?
Yes, sir.
Yes, sir.
है ना? So sigma dash will just move with the opposite velocity of B, because we have to calculate velocity of A with respect to B. This is my S frame. This is my S frame. This is my sigma, is my S dash frame. So now, what will be your picture? Your picture will be, this is your S frame, that is B actually, and this is your x-axis, and this is your sigma, and sigma is moving in which direction?
Negative x.
Negative x direction. With what magnitude? V magnitude. So you can just put minus into I cap direction. And your A is moving something like this, U. Are you getting my point? And this angle is basically theta. Yes? Now, you can easily say, what will be velocity of S dash with respect to S? बताओ तो क्या होगा?
Minus v.
Minus V in which direction? I cap direction. Now, velocity of particle with respect to S dash. I am talking about velocity. So what will be velocity of particle with respect to S dash? You have to take two component, one component along x-axis and another component along y-axis. So what is your ux dash? Just tell me.
Cos theta.
Very good. So that value is u cos theta. What is your ui dash?
2 sin theta.
U sin theta. Now, which formula you are going to use? What is your ux?
Ux dash plus
Mhm.
plus v.
Plus v. Very good. 1
by
plus
1 plus
ux dash v
by
upon
c.
c square. So what is your ux dash? U cos theta. What is your v? Minus v. 1 minus u cos theta v upon c square. And similarly, what will be your ui? Ui is equal to ui dash root under 1 minus v square upon c square.
Sir,
Yes. बताइए.
सर क्लियर सर, वो मुझे u cos थीटा की जगह वो c वाला डाल.
क्या c वाला क्या डाउट था?
सर वो लास्ट क्वेश्चन में जैसे वो c cos थीटा आपने नीचे लिखा है ना, वो टर्म कैंसिल हो गई थी.
हाँ.
मैं थोड़ा सा कंफ्यूज हो गया था उसमें.
वो तो बाद में पूछना, अभी इस क्वेश्चन पर ध्यान दो. ठीक है. एक बार थिंक करना, कहीं कुछ प्रॉब्लम होगा तो बात कर लेंगे. ठीक है. So you can just go for ui. What is your ui? What is your ui dash? Ui dash is u sin theta root under 1 minus, what is your v? Is same v, so v square by c square, and you have 1 minus u cos theta v upon c square. So you have two component of this one, and you can easily calculate this one. Now suppose someone will ask you, what will be velocity of b with respect to a? Then what is going to happen? तो क्या हो जाएगा जरा ये बताओ.
X axis along ये खींचेंगे.
Very good. So this will be your x-axis. Okay. And then, so now जरा मुझे नोटेशन से बता दो. What will be velocity of s dash with respect to s? ये क्या लिखोगे?
प्लस VL
minus u.
Minus u. So that will be minus u in I cap direction. What is your ux dash? ये क्या होगा?
use
हाँ, सोच करके.
v cos
V cos theta. So that value is V cos theta. What is your ui dash?
minus v sin theta.
You can take plus or minus, so there is not any problem. Sin theta. Okay. So you can just use this type of trick when there is not any particular direction is given. But in general, the examiner will give you direction. But if they are not giving you any particular direction, then obviously you will always try to make your S frame moving along X direction. And what is your S frame? From where you want to see the particle at the final level. So this trick you can easily use and you can calculate this thing. Okay?
Sir,
हाँ बताओ.
सर मुझे ये चीज ही नहीं बस समझ आई कि पार्टिकल A is making an angle theta with the B ना. तो जब हमने फ्रेम डिफाइन किया कि S फ्रेम इज B, सिग्मा इज आवर S डैश, तो पार्टिकल का जो थीटा है वो हमने सिग्मा उसमें
ये दोनों किसके रेस्पेक्ट में जा रहा है? सिग्मा के रेस्पेक्ट में जा रहा है. ओके. तो सिग्मा के ऊपर आप बैठ रहे हो तो ये ए और बी के बीच में आपको एंगल थीटा दिखाई दे रहा है. आर यू गेटिंग माय पॉइंट?
ओके सर.
ठीक है. सो व्हेन यू आर सिटिंग ऑन सिग्मा, दिस एंगल इज थीटा. नाउ यू आर सिटिंग ऑन बी, तो व्हाट विल वेलोसिटी ऑफ बी विथ रेस्पेक्ट टू यू? जरा बताओ क्या होगा. If you are sitting on B, what will be velocity of B with respect to you? If you are sitting on car, what will be velocity of car with respect to you?
Zero.
Zero. So if you are sitting on B, then what will be velocity of B with respect to you? Zero.
अच्छा u वो u
Yes. Okay, you means me with respect to me.
हाँ,
Okay,
with respect to
okay.
you.
Okay, sir.
Y O U.
I was
Okay.
thinking,
वो
I was confusing about you.
No,
that
no,
is the
no.
reason.
That means
Okay,
this U.
okay,
Okay.
okay,
Y
okay.
O U.
Okay, sir. Okay.
ओके. ओके. सो जब आप इसके ऊपर बैठोगे तो आपकी वेलोसिटी इसके रेस्पेक्ट में क्या होगी? जीरो होगी.
Yes, sir.
ठीक
Yes.
है. जब आप यहां पर बैठोगे, then this sigma will appear to move you with what velocity?
Negative of
Negative.
in reverse direction. Yeah.
In reverse direction. So that will be minus V. Are you getting my point?
Yes, yes, yes.
And this is S dash frame. So this will be UX dash, UI dash, UZ dash.
Yes, sir.
So you can just, and because A is, what is velocity U? What is U? Just tell me. What is definition of U?
Velocity of particle with respect to
Velocity of A with respect to sigma.
Yes,
isn't
sir.
it?
Yes, sir.
Are you getting my point? Now you are saying that sigma is your S dash. So this will be something like UX dash, UI dash, and UZ dash.
Yes.
Isn't it?
Yes. Sir.
Just try to do with yourself. Try to convince yourself. And if you have any doubt, then we can talk again. Okay? Okay. So these are the some problem of mainly relative speed, and you will see whenever the STR will come, relative speed is most important thing because it will come everywhere. Everywhere you have to solve this particular the speed of A with respect to B, and then after then you have to calculate something. So when you will use Lorentz transformation, there are some main observations are there. So the first observation is very interesting, that is very popularly known as length contraction. So let's try to understand what is length contraction. Okay, so let's try to go for a next topic, that is length contraction. So first we have to talk about rest frame. So what is meaning of rest frame? Meaning of rest frame is that if your velocity and frame velocity is same, that you are in the rest frame of that particular frame. So we have to be very much clear. What is length contraction? The one liner for length contraction is moving rod. If I am talking about rod, that means I am talking about length actually. Okay. So moving rod appeared shorter. Now what will happen? If you will sit on rod, that means there is not any relative speed between you and rod. You means you. Okay. So, or if rod and observer are in same frame, then there is also not any relative speed between them. So what will happen? Suppose your rod is not moving with respect to you. So if your rod is not moving with respect to you, you will see the proper length. So first we have to define proper length. If relative speed between length of rod and observer is 0, then observer will measure proper length. Then observer will measure proper length. So if relative speed between observer and length of rod is 0, then you will always measure what? Proper length. You can just assume, suppose this is your length. So I am just taking my mobile and you can just assume this is your length. And I am moving with the same speed of this mobile. Okay. I am also moving with the same speed of this mobile. So what I will find this length is proper length. But if the length is moving with respect to any observer, so if length of rod or length is moving, if length is moving with respect to observer, then observer will measure contracted or shorter length. Now, what is meaning of length? Meaning of length, you are watching these two end simultaneously. Are you getting my point or not? When you can perceive length, if you are seeing only this point, then can you perceive length? No. It is shorter or greater. How you see? When you will see these two edges at the same time. So let's first derive this particular length contraction, and then we will try to solve some problem. And here, the most important thing is that you have to just see the length and relative speed with that length. So this is very interesting. I will just discuss when we will go for one problem. So right now, let's try to derive this particular thing. Okay. So everyone is comfortable right now? है ना? So let's try to go for this. So look at what is going to happen. This is very interesting. Suppose we have as dash frame and a rod is along the x-axis. So this is your rod lying along the x-axis, and there is observer in a S dash frame. This observer A is rest with respect to S dash, and this rod is also rest with respect to S dash. So velocity of A with respect to S dash is 0. Velocity of rod with respect to S dash is also 0. So that means A will see proper length or contracted length?
Proper length.
Proper length. So the length he will measure is something like x2 dash minus x1 dash is equal to L naught. Yes? How you will measure length? You will probe at this point and you will probe at this point, and you will see what will be the distance between them. You can find the proper length. Now suppose this S dash is moving with respect to S. Suppose this S dash is moving with respect to S. Then there is another observer who is B. And B want to see the length. So what will be length measured by B? Obviously
Sure.
x2 minus x1.
It's less than L naught.
That is L? Sorry?
Is less than L naught.
Should be less than L naught. So we have to prove that thing. Okay.
Okay.
So now this is x2 minus x1 is L. And let's see that what is this particular L. So we have Lorentz transformation here. Everyone is comfortable? So let's try to go for Lorentz transformation. So x2 is equal to x2 dash is equal to x2 minus vt2 root under 1 minus v square upon c square minus x1 minus vt1 root under 1 minus v square upon c square, and that should be L naught. Everyone is comfortable? I can take a space pause together. So x2 minus x1 upon root under 1 minus v square upon c square, and minus I can take v t2 minus t1 root under 1 minus v square c square must be equal to L naught. Everyone is comfortable? Now here is the most important concept, and you have to just think. Listen, if this person want to see the complete length, he will see this 2 point at the same time or two different point or two different time.
Same time.
Same time. Now you can see, you can do this experiment in your daily life. You are just watching the plane moving in a sky. Yes, देखते हो ना प्लेन जा रही है स्काई में. Now बचपन से ही हम लोग करते थे या फिर अभी भी आप करते होगे. I used to do this thing. You just want to measure the length. आप जरा उसको लेंथ देखने की कोशिश करो कितना बड़ा आपको दिखाई दे रहा है. So what you will do? You will pick one finger or you will just use something like this. Are you getting my point? If you want to see the plane, then plane is actually this plane is very big. When it is rest with respect to something, or if you are in front of that particular plane. I am not saying that this is your STR question, but this is your something height and distance question, and how your angle, how your eye is making angle with that particular length of the plane. That is, this question is something like that. But my question is that if you want to perceive the length, then what you are doing? You are just seeing the two end at the same time, isn't it? Then only you
Yes,
can
sir.
perceive whether plane is this much or this much or this much, isn't it?
Yes, sir.
So that means when this person want to perceive this particular length, what is condition for length contraction? T2 minus T1 is equal to 0. He had to see these two lengths at the same time. And then T2 minus T1 is equal to 0. And then you have x2 minus x1 is equal to L0 1 minus V square upon C square. And what is x2 minus x1? Is the length measured by him. So you can see L is equal to L0 1 minus V square C square. And you can easily see this L is less than L0. Isn't it? This L is less than L0. And this is all about the length contraction. And most important point is that proper length is uniquely measured. And there is unique frame from where you can measure the proper length. And what is that unique frame? In which frame the length of rod is rest with respect to you. Are you getting my point or not?
Yes, sir.
Okay. So always keep in mind that proper length is uniquely measured. So what is this length? This length is L0, and which is proper length 1 minus V square upon C square. Now suppose there is some another frame. And let's say this is some S double dash frame. Then if this person will see this one, obviously he will see the different length, but the proper length for this person and this person and this person is always remain what? Same. So proper length is uniquely defined. Why? Because you have to measure proper length when you will jump from when you have to in the rest frame of S dash. And there is one and only one unique frame where the rod is going to be rest with respect to observer. And suppose I am just putting my rod something like this, and this is moving in X direction, I cap direction, then what will be length contraction?
0.
0. So there is not any length contraction. Okay. Why? Because along the length, there is not any relative speed. Are people going to understand this particular thing? You have to always try to check it. What will be relative speed along the length of the rod? Along the length of the rod. And that relative speed will only contribute in the contraction. We will just solve one problem and then you will see how we can use this concept of length contraction. So yes, one liner for length contraction is all about moving rod appeared shorter or appeared contracted. And this is very important length contraction. Okay, so let's try to go for one problem. But before that, if you have any doubt, you can just raise your question. Yes, anyone? Everyone is comfortable? Chalo. So let's try to go for one beautiful problem. And let's see this problem is very easy, but it will just enough to understand the concept of length contraction. Okay, let's try to go for this. What is this? Suppose we have S dash frame and the proper length from S dash frame is given by L naught. A rod, we have one rod whose proper length is L naught with respect to S dash. That means the rod is rest with respect to S naught, S dash, isn't it? Everyone is
Yes.
comfortable?
Yes, sir.
If I am saying that the proper length of rod is L naught with respect to S dash, that means the rod is rest with respect to S dash. And it will make some angle theta naught with respect to S dash. And here, this S dash is moving with velocity v in I cap direction with respect to S. This S dash is moving along X direction with velocity S. So there is observer on S. The question is that what will be length of rod measured by observer A? Let's say he is observer A. Everyone? So now, how you will see? Look at here. So this rod has two component of length. One is along x-axis, another is along y-axis, isn't it? So what will be x-axis, the proper length along x-axis?
L naught cos theta.
Very good.
Naught.
So proper length, so I can write this thing at something like x, Lx naught, because we are talking about proper length. So naught is the notation for proper length. Okay? Lx dash naught. What is this value? बताइए क्या होगा? L naught
Cos
Cos
theta,
theta.
cos theta naught.
cos theta naught root under 1 minus v square upon c square. Isn't it? Sorry. This will be Lx naught is L naught cos theta naught. Sorry. And what will be L y dash with proper? क्या हो जाएगा ये?
L naught sin theta naught.
L naught sin theta naught. Very good. Now, what will be Lx? Now I am not saying any proper or anything. What will be Lx now?
Lx naught dash under root.
Very good.
1 minus v
Lx
square.
naught dash root under 1 minus v square upon c square. So what will be this value? This value is L naught cos theta naught root under 1 minus v square upon c square. Isn't it? So this is your proper length. Sorry, this is your length, proper length or contracted length?
Contracted length.
Contracted length. Now, what will happen to Ly? Is that it is going to contract or remain same?
Remain same.
Remain same.
Remain same. Why? Because there is not any relative speed along y direction. This is along x direction. So what will be that value? That value is L naught sine theta naught. So what will be complete length of the rod? The new L is equal to Lx square plus Ly square root under. So this will be the complete length. This is my Lx from here. This is my Ly from here. So I can easily calculate it. Now look at the magic here. It's a very interesting. So what is Lx square? So this is your L naught square cos square theta naught 1 minus v square c square plus L naught sin square theta naught. Everyone is comfortable right now?
L naught square.
L naught square. Very good. So I can take L as a common, L naught as a common, and we have cos square theta plus sin square theta is equal to 1. Yes? Minus v cos theta naught by c upon c square. Just check it whether it is correct or false. Just check my calculation.
Right, sir.
Right. This calculation is correct. Now you can see it's a very interesting. What is V cos theta naught? Can anybody explain what is V cos theta naught?
Component of V
Component
along
of
L naught.
velocity in x direction.
Component of velocity along
L naught.
L not that
L direction. So the component of velocity along the length of rod, the component of velocity along length of rod is equal to V cos theta naught. So this is beauty. So only those part of velocity is going to used for the contraction, which is actually parallel to this particular rod, isn't it?
Yes, sir.
सर थीटा अब इनवेरिएंट है से थीटा
Sorry.
हमने थीटा के लिए किया था थीटा वेरी कर रहा था कब
नहीं वो तो सॉरी थीटा तो वेरी करेगा ही आप यहाँ पर tan थीटा की वैल्यू निकाल लो चेंज हो जाएगा व्हाट इज tan थीटा नाउ व्हाट इज tan थीटा दैट इज ly अपॉन lx यही होगा ना व्हाट इज दिस l नॉट sin थीटा नॉट by l नॉट cos theta naught 1 minus v square upon c square. So your new angle is basically tan theta naught by root under 1 minus v square upon c square. So what is problem into that thing? Yes, this person will also see different angle. He will not see the same angle. But my question is not that. My question is that when this length is going to contracted, which part of the velocity is using for this contraction?
So that is v cos theta.
That is v cos theta. So now again you can go and read the definition very carefully. What I am saying, if relative speed along the length, are you getting my point or not? Relative speed along the length. So what is relative speed of the rod with respect to observer along the length of the rod? What is that?
V cos theta.
V cos theta. And that is actually using into length contraction. Everyone is comfortable? So let's try to go for one more problem. यहाँ तक clear है ना? And yes, you are 100% correct that this angle is not same of the observer who is sitting on S dash. It is entirely different angle when observer is sitting on S. That you can easily calculate. Yes? यहाँ तक clear है? Okay. Let's try to go for one more problem. So there is a circular disc. Okay. This question was asked in your exam also. So there is a circular disc, and this circular disc has area A. This has area A. And this disc is moving along x-axis with velocity v with respect to observer. So this is your x-axis, this is your y-axis. What is going to happen? This disc is moving with respect to observer with velocity v along x-axis. So what will be area measured by the new shape? First of all, first question is that what will be new shape? नया shape कैसा नजर आएगा?
Elliptical.
Elliptical. So अब elliptical में दो possibility हो सकती है. One possibility is something like this. Another possibility is something like this. Which possibility is there?
दूसरा वाला.
Second
ये
one.
possibility.
No, sir,
Sorry,
no.
sir, पहला वाला,
First
पहला
short
वाला.
answer.
पहला वाला. क्यों होगा पहला वाला? Why?
Length
Because
contract.
this is just going to contract. And obviously, please just check what will be the center. Center क्या होगा ये भी आपको check करना है. And this will be your homework. What will be center of new ellipse? ठीक है? You can just easily check. Now but I am considering for the area. Okay. Good. So what will be area of the ellipse? Suppose this length is A, this length is B. So what will be area of the ellipse?
Pi AB.
Pi A into B. So this will be area of the ellipse. Okay. Now we have to write this area as area of circle. Here is the trick. What will be area of circle? So what should be the radius of this particular circle?
Pi r square like r or a x is area.
सोच कर बताओ. What should be the radius of this circle? ये figure से बता सकते हो?
Small a. or
Small a?
No, B.
Small
should
b.
be the radius.
Why? Because this length is not going to contract. All other length is proportionality going to contracted, but this length is not going to contracted. So if this length is not going to contracted, so area of this one is pi b square. Yes? So this will be your A. So you can write pi b. Now anyone can tell what will be A here? What will be A here?
L.
L कहां से आ गया?
B into
हाँ?
root under 1 minus v square.
Exactly. So this A, so this is just going to contract. This length is also what? B. This length is also going to what? B. Now this B is going to contracted up to A. So your A is nothing but B root under 1 minus v square upon c square. So pi b and A can be written as B root under 1 minus v square upon c square. And what will be your pi b square?
Area of circle.
Area of circle, that is A. So root under 1 minus v square upon c square. So this will be your new area. Area, new area. Okay, area of ellipse likh do. Okay, and this area is less than this one, isn't it? Due to this particular length contraction. Now my question is that if the equation of this one, so I can assume this is my S frame, this is my S dash frame. So what will be equation of this one, this circle? What will be equation of this circle?
X dash square plus y dash square is equal to b square.
X dash square plus y dash square is equal to what? B square. Okay. Now, what will be equation of this shape appeared from S frame? So you have to do what? Lorentz transformation? Yes या no? करना पड़ेगा ना? So what will be this Lorentz transformation? X minus Vt whole square plus, and this is what? Root under 1 minus v square upon c square whole square, and that value is y square is equal to p square, and now you can see x minus vt whole square upon b square root under 1 minus v square upon c square plus y square upon b square is 1. What is this equation?
Ellipse.
Ellipse. And now you can see the this part is shorter than this one. This is shorter than this one. You can see, isn't it? So after time t, this person will see this is not at 0, 0 coordinate, but rather this is at vt and 0 coordinate, isn't it? According to this frame. So yes, this type of problem can come into your exam, and this thing is nothing but the length contraction is nothing but the application of what? Lorentz transformation. We have proved this thing with the application of Lorentz transformation. यही तो किया था ना? Once you know Lorentz transformation, then only you have length contraction. Don't worry. Okay. So we will just stop this class here. Tomorrow we will solve different type of problems for the length contraction. Okay. If you have any doubt, you can just ask me. Any doubt? Chalo. So we will meet tomorrow and we will proceed ahead. ठीक है? Thank you.
Thank you, sir.